Hello students. So today we will discuss while loop, which is another important looping structure in C. So the general syntax of a while loop is while test condition followed by the body of the loop. So where this test condition is a logical expression which evaluates to either true or false, the body of the loop is executed as long as the test condition remains true. Right? When the test condition becomes false, the body is not executed. So since the test condition is evaluated at the beginning of the loop, so the while loop is called an entry controlled loop. Right? So let us start with an example. Program to find the sum 1 plus 2 plus up to n using a while loop. So hash include stdio.h, void main, these are compulsory. We start with a variable n, integer variable I equal to 1, and sum, we initialize the sum to 0. So printf enter n, scanf %d ampersand n, this will take the input of n, and while I less than or equal to n, sum takes the value of sum plus I, and the value of I is incremented, I plus plus, right? And then printf, the sum is this. Okay, so this is a simple program to see the application of while loop. So just let us run it and see what happens. Sorry, this will be gedit, yeah. Okay, so just let us quickly write this. Hash include stdio.h, and then void main followed with the brackets integer. This is the integer that that we want. Then this is the counter variable I equal to 1, and then this is counter variable or loop control variable, and then this we initialize the sum to 0. Okay, and then see printf this happens, printf enter n, and then it is scanf %d comma ampersand n. Okay, then here I need to write the loop for sorry, I'm not writing the for loop, I'm writing the while loop. While I less than or equal to n, okay, while I less than or equal to n, sum takes the value of sum plus I. Okay, and I is incremented by 1. I can write I plus plus, or we can write I equal to I plus 1. Okay, so after that we'll print the value of sum. So it's 1 plus 2 plus 3 plus dot plus n equals %d comma sum. Okay. So this is our program, very simple program. Let's see. GCC prog 12 for while loop dot c dash o prog 12 while loop. Okay, so there is no error. So prog 12 while loop, enter n, say 5. So the sum of 1 plus 2 plus up to n is equal to 5, right? Say 10, it's, yeah, did I do some mistake? Yeah, 10, it's 55, it's okay, correct. So this was our program to verify this, to illustrate the while loop. So let us try to understand how this program works. The program works as follows. Initial value of, say we take n equal to 5, the initial value of I is 1. So while I less than or equal to 5 tests if I is less than or equal to 5 or not. So when I is 1, I less than or equal to 5 is yes, it is correct, it is satisfied. So what happens, the control goes inside the loop, and sum is new value of sum is taken as old value of sum plus 1 plus I. Okay, so there is 0 plus 1, and then there is an increment statement I plus plus. So the value of I is incremented by 1. Again it is checked whether I is less than or equal to 5 or not, the test condition. So 2 is less than or equal to 5, it is correct. So again the value of sum becomes sum plus I. Again the value of I is incremented, value of I becomes 3. So it's very similar, just as we have done in for loops. It's similar to that. So 3 less than or equal to 5, that is also correct. So sum takes the value of sum plus I, again incremented by 1, so value of I becomes 4. 4 is less than or equal to 5, so this is also correct. Again sum becomes sum plus I, then value of I is 5. 5 is less than or equal to 5, that is also correct. So sum becomes sum plus I, and then value of I is becoming 6. So 6 less than or equal to 5, it is incorrect. So here we will stop. Okay, so that is how this for while loop runs. Okay, so let us see another program to display the multiples of 11 less than a given number, right? So int n I equal to 1, printf enter n, %d ampersand n, these are the same thing. Only the thing is that this test condition is a bit different. Okay, so while 7 star I, we started with I equal to 1, so the first multiple of 7 will be, this will not be 7 star, this will be 11, it will be 11 star, because we are considering multiples of I, 11, sorry. So this will be 11 star I. Okay, please make this correction, it's 11 star I. Okay, while 11 star I less than or equal to less than n, printf, this particular value is also 11 star I. Okay, just let me cross mark it, it's not 7 star I, it's 11 star I. 11 star I. Okay, we are considering multiples of 11. Okay, so just let us see how this program runs. gedit program 13 while loop.c, and let us run it. Hash include stdio.h, and then void main. Okay, then int I and n, and initialize I to be 1. Okay, so printf enter the upper limit, or say enter n, then scanf %d ampersand n. Okay, this, and then while so let us write this statement also. Printf the multiples of 11 less than %d are \n, n, right? I have to get the value of n here. While 11 star I is less than or equal to n, less than n, right? This will be, while 11 star I is less than n, printf %d \t 11 star I. Okay, this, and then I give one I plus plus statement here. Okay, so this is the program. GCC program 13 dot while loop program 13 dot slash program 13. Okay, so enter n. So what do I want? I want the multiples of 11 which are less than 6. So there are no multiples less than 6. So say enter 1000, multiples of 100, multiples of 11 less than 100 are what? These are the multiples of 11 which are less than 100. Okay, so this was the program. Then say program to display the digits of a given number. So for this we need a little bit of number theory. If a number is divided by 10, the remainder that you get is actually the unit digit of the number. Only this concept is required, nothing else. So we start with n, q and r. Sorry, there is a semicolon here. I made a lot of mistakes today. There should be a semicolon here. Okay. So printf, enter a positive integer. Right, scanf %d %n. So initially we take q as n and printf the digits of %d from left to right. So we shall be starting with the unit digit. So first of all, what we do, we divide q by 10. So if it is a one digit number, in that case there is only one digit. But even then, that one digit divided by 10 will give you the remainder as that particular one digit only, and the quotient will be 0. So the loop will keep on running as long as the value of q is non-zero. So here, while q is non-zero, r equal to q %10 printf %d \n r. Okay, so we'll print the value of r, and then q will take the value of the quotient when the number is divided by 10. Okay, so suppose initially your number is, say, q is equal to 156. Okay, so initially your number n is 156. So q will take the value of n. So q is non-zero, right? So value of r will be 156 %10. So which is evaluated as 6. So 6 will be the unit digit, and r equal to the value of q, new value of q will become 156/10, and that evaluates to 15. Okay, the quotient when 156 is divided by 10, right? So q is again non-zero, so the loop will run again. So the value of r will become 15% 10, right? And that comes out to be 5. So we get the next digit, right? Then value of q will again become 15 divided by that /10. So that will evaluate to 1. Okay, and then the value of r will be now 1% 10. So that is evaluated as 1, and the value of q now will be 1/10, which is equal to 0. So when value of q becomes 0, so q will become 0 when we come to the last digit from the right side. Okay, so in that case q will become 0 and the loop will stop executing itself. So if so this is the important point that we have to note. Important point here is that if a number is divided by 10, the remainder is its unit digit. Okay, so let us see how this program runs. So this was the program. It's 14 while loop.c. Yeah, this is already written. Int n, q and r. So enter a positive integer, then initialize q to n, and printf the digits of %d from left to right are this. While q not equal to 0, r takes the value of q %10 remainder, and q takes the value of q/10. Okay, so let us see how this runs. What happened? 14. Okay, I did not compile this probably. GCC, let us compile this. -o prog 14 while loop. Okay, so this is enter a positive integer. So I enter something like 4789. So the digits of 4789 from left to right are 9874, right? Say another one, I enter something like 12, so it's 211. Yeah, I enter 5, it's 5. Okay, so this is the program to display the digits of any number, any given number. So using the same concept, we can find we can write a program to find the sum of the digits of a number. Everything is similar, only a new thing is introduced here, the sum variable. So instead of displaying the digits, we just add up the digits to sum. So we initialize sum to 0 and sum is taken as sum plus r. Okay, so let us see that program also. This gedit program 15 while loop.c. This is the program that we have written. Sum equal to sum plus r, q equal to q/10, and the sum of the digits will be printed. Okay, so let us run this program. GCC program for 15 while loop, then program 15 while loop, right? This is, and then run it. 15 while loop. Enter a positive integer, say 123. I should get the sum of the digits as 6. Okay. Yeah. So here what you see, the sum of the digits of 123 is something like 11825004150, but it should have been 6. So there is some problem in our program. So let us see what is the problem. So yeah, if you can find out, it's the problem lies here. We had used the variable sum, int variable sum, and then we have also used this sum equal to sum plus r. But the problem that I have done is what? The mistake that I have done is I have not initialized sum to 0, right? So we have to initialize the sum to 0. Since it was not initialized, so the system has taken, as an initial value of sum, the system has taken the garbage value, any garbage value. Okay, it depends on the system. I am getting this result. In your system, you may get some other value. So it's called a garbage value. Randomly, some value will be taken by the computer, and the program will be executed. Okay, so let us do it properly now. 123. Now see, the sum of the digits is 6. Okay, now the program is fine. So 456, the sum of the digits is 15. Okay, so that is how we find out the sum of digits of any given number. Okay, now a little bit more of mathematics. Program to find the HCF or GCD of two numbers using Euclidean algorithm. So first of all, let us recall Euclidean algorithm, so which you will also be doing in the number theory course in this semester itself. So suppose we want to find out the GCD of 12 and 30, and this particular Euclidean algorithm you have already done in school level as well. Okay, so it's 30 equal to 12 into 2 plus 6. Okay, that is how we apply the division algorithm to 30 and 12. So then the divisor in the first step is taken as dividend in the second step. Okay, that is how we do. You can have a look here. That is how we have done in school also. So 30 is divided by 12, and the remainder comes out to be 6. Then this 12 is taken as the dividend here, and then it is again divided by 6. If the remainder comes out to be 0, the last non-zero remainder is your GCD. Okay, so that is how the division algorithm works. So apply division algorithm. So once the remainder comes out to be 0, the GCD is the last non-zero remainder. Okay, so the remainder obtained in the previous step. So as another example, say 306 and 657. Suppose we want to find out the GCD. So 657 can be written as 306 into 2 plus 45. 306 can be written as 45 into 6 plus 36. Okay, 45 can be written as 36 into 1 plus 9. 36 can be written as 9 into 4 plus 0. So the last non-zero remainder, okay, the last non-zero remainder here is the GCD. So GCD is 9. So let us understand this symbolically. Denote the dividend in each step by capital D, divisor by small d, and the remainder by r. So initially capital D is one of the given numbers. Two numbers will be given to you. You take one of the numbers as d and other number is small d, and then you set r to d%d. You calculate the remainder when d is divided by capital D is divided by small d. If r is 0, then small d is the GCD itself. If one number is divisible by the other number, the smaller number is the GCD, right? If r is non-zero, what happens? We take the new value of d is taken as the old value of small d, and the new value of small d is taken as the earlier remainder that we have got. So we have to assign d as capital D as small d and small d as r, and then again we'll compute what is r equal to d percent d. If r comes out to be 0, the current value of d, small d, is the GCD. Otherwise you reassign d and capital D and small d and continue. Okay, so let us see this program. So we have these two are the given numbers, a and b, and capital D, small d and r, these are the numbers we will be using for our computation. So printf, you enter two non-zero numbers, so preferably we are taking non-zero numbers. So ampersand a, ampersand b. So we assign a to d and b to small d, right? And then we compute what is d percent d. So while r non-zero, if we get zero remainder, then we don't need the loop, right? So while r not equal to 0, d equal to capital D is small d will take the value of r, and then again we will compute r equal to d percent d. So this process will keep on running as long as the value of r remains non-zero. So once the value of r becomes 0, we already get the GCD. What is GCD? The value of small d that remains. Okay, the value of small d that remains in the earlier step is the GCD. Okay, and what is the LCM? LCM is all of us know that the product of two numbers is HCF into LCM, right? GCD into LCM is equal to the product of two numbers. So once we get the GCD, it's very simple to find out the LCM, a star b divided by d. Okay, so let us have a look at this program. So it's gedit program 16 while loop.c. So this is the program we have written to find out the HCF or GCD of two numbers, right? So let us run this, compile this. 16, so this is 16, and then you run it. 16, enter two numbers, say 5 and 3. What should be the GCD? GCD should be 1. Okay, GCD of 5 and 3 is 1. LCM is 15. Okay, say I write something like the number that we had taken, 306 and 657. Okay, so GCD is 9 and the LCM is this. Okay, so other numbers also you can try. It is always better to try with some trivial numbers, say 1 and 69. Okay, and then let us try with 69 and 1. Okay, so the GCD is 1 and LCM is 69. Okay, so let us try with 0. We have not written anything extra about 0. So if I take a as 0 and b as 6, the GCD is 6. Okay, but there is a problem. If I take 6 and then 0, then there will be a division by 0 error. Okay, so we are avoiding this 0 things here. So in general, the GCD of 0 and a non-zero number is the non-zero number itself. Okay, so these are some examples of programs written using the while loop. So in the next video, we will be doing do while loop, which is also a very important loop structure in C programming. Okay, thank you.